Okay, Michael. So here's the definition of the reward function S comma O. It's an expectation over the set of rewards that I'm going to see, discounted at each step by gamma. So the first reward that I see, R1, at step 1 is going to be R. At step 2, it's going to be R2, discounted by gamma. At step 3, it's going to be R3, discounted by gamma squared, and so on and so forth, until the option ends after k steps. And that final reward will be discounted by gamma to the k minus 1. So this is, in some sense, the average, in fact, in a very particular sense, this is the average discounted reward that I will see by executing this option in this particular state. Does that make sense?
Yes. I mean, I guess it's weird because it's kind of immediate reward in the sense that it's the reward that comes from that executing that one option, but it's also clearly not immediate reward. It's a sum of rewards.
Right. So one way of thinking about this is, remember, all an option is a policy that I'm going to execute. That policy will be realized in specific actions, which means it will be realized in particular states and rewards that I will see, a bunch of SARs. So even though from the outside I start here in this particular state, some time passes and I end up in this state, what's actually happening along the way is I'm visiting every single one of these states and picking up reward along the way. But we need to be able to discount that reward, and so the discount factor is hidden inside of the reward function. So this is as if, rather than executing the option, I had actually just executed all the atomic actions that the option itself will in fact execute.
And then you'll call that sort of one bolus of reward.
Right, because all that's really happening, right, is that whenever you have this kind of summation over you're seeing a bunch of states and taking a bunch of actions, all you're doing is adding up all the rewards you're going to see. Remember, we got the Bellman equation by just writing out that we're going to visit a whole bunch of rewards. That the definition of the value of being in the state is the expected discounted reward.
So, and we're keeping that consistent here in this abstracted, temporally abstract actions setting, by virtue of the fact that still the immediate rewards are discounted according to the true time steps of the underlying process, even though we, I guess, as the agent, get to think at a higher level. We get to think about an action taking multiple steps.
Right, exactly. And so we do something very similar for F, and we end up with this nice equation.